There we go. All right, hey everyone. So we're gonna get started on the next stream, the second live stream I've been doing. I've gotten, if you haven't seen this already, I've gotten a little page set up for these streams for the future now, with some links that we'll be using, and then I'll also be like, as I work things out, I'll be adding stuff here. So after the streams, there'll be a spot for you to be able to reference stuff and see prompts and the kinds of things that we work out. Okay. Was there any questions anyone had before I get started here in general? Anything from the last live stream that you wanted me to touch on real quick? Okay, that's no problem. I'll get started and I'll check comments here and there. I'm doing yeah, if anyone wants to do a local recording to the device, that'd be really helpful. You just click the hit more, and then you can do at the top of the options will be recording. I'm doing one to cloud, but I'm not doing one to my device right now. All right, I'm gonna toggle off my video and then we're gonna get started. Interest in KR, applications of it. Yep. Okay. So I was asking for the community for ideas for a solution space to model for the stream, and Jimmy has had a really good idea in general the last few weeks or months, I guess, for stuff that can be done with personalized lesson plans, right? So we're going to be working on this idea. I'll go over in more detail, but that's going to be the solution space that we build for today, okay? Just for some context on that. Okay, so first, this will all make sense as we go through it, but I want to start off by doing a little bit of a deep dive into ChatGPT and the different mechanics and stuff at play here, and then we're going to basically build upon everything ground up. Okay, so the two things in the stream I'm going to cover is more in-depth mechanics of ChatGPT and the architecture they have, and meta-prompting fundamentals. Okay, and we're going to do this by setting up a meta-prompt from scratch for this solution space. Okay, now everything's going to come together, and we're going to be referencing quite a few things here, so it'll make sense as you follow along. Okay. But let's start with looking at the OpenAI system prompt in a little bit more detail right now, real quick. I just pulled this today, so this is the system prompt that's live right now. They've been doing a update where they've been rolling out the newest update of the model to ChatGPT over time. But how they do this, it's very random how they do it. They incrementally release it to different people, and they don't even tell you when you get it most times. So it's just kind of random. Either way, the system prompt is changed at the same time for everyone when they make changes, and it stays consistent between sessions depending on that. All right. So this is a meta prompt, right? This is a meta prompt the same way the Anthropic meta prompt is a meta prompt, right? This is meant to set up high-level instructions for downstream tasks, okay? And they use this system prompt to enable a lot of different things. OpenAI have been the masters at emergent tool behavior, right? And they've had a system working to exploit this for years now already. So there's a lot of details and things that can be gleaned from understanding the system prompt. Anytime I'm building in ChatGPT or GPT in general, I always make sure I am up to date on the newest version of the system prompt, because anything they change here impacts anything you do, especially with prompting or downstream solutions. Okay, so let's just start from the beginning here. Let me zoom in a little bit. Okay, so establishing the highest level instructions for everything, right? Establishing who the model is, who was trained by, what the architecture is, right? Very simple. Okay. They have some basic lines in here to establish the dates for cutoff. It's been fine-tuned to understand all this stuff. So this just helps anchor in certain things into the prompt, okay? They have a variable here for input, image input capabilities, right? It's basically just, this is something to keep in mind here, how they have these two things here as input variables, but not actually defined out what they are. It's how you know there's been something that's been fine-tuned, and this is just anchoring it in the understanding, okay? Now, let's go to Python tool, which is still OpenAI's best work. There we go. Right, so there's almost zero instructions for the Python tool, all right? And that's very intentional, right? Because anything they set here would hard impact anything that was done, okay? The reason why is how this is set up, right? They want to leave as few instructions as possible to keep things as emergent as possible, okay? That's how it works, performs the best. All they really do here is give some basic details about the drive it has access to and the files. Internet access for the session is disabled, right? They actually have the ability to enable this model with internet access, but they just don't have that enabled publicly, okay? And they have to explicitly tell it to not make external web requests or API calls because it would try if they didn't include that here, right? But outside of this, this is the only real instructions that they have for Python tool. Ideally, this is how the instructions would look for every tool, right? But why is it not the case? Well, because of safety and filtering, right? There's a bunch of different things they don't want Dolly to do. There's a bunch of different things they don't want the browser tool to do and stuff like that. So that forces explicit instructions. That forces a lot more granularity to be ironed out here, okay? And that's where you start getting into a lot of issues, right? But anyway, let's talk about the overall structure first, okay? And the syntax, right? OpenAI uses a markdown superstructure syntax, okay, to delineate the main sections of the prompt, okay? So despite all the details here, you can see the superstructure at work here, MD, right? Delineating the different tools, okay? There's actually more after this that sets up the user profiles. And if you have custom instructions, that's where they will be injected into, right? And when you have RAG enabled by uploading a file, it'll add in a RAG section here and change the browser instructions as a result, because they both actually use the same system, just with different information sources, okay? So MD superstructure, and inside each of these layers, right, you can imagine that each of these delineated headings, right, the space underneath this, between this and the next heading, is almost its own layer, right? So you can include different syntaxes and different things inside these different layers, right? And it's not a problem. It'll be able to understand things in the delineated way that you were intending, simply by using this kind of format, right? So because GPT is fine-tuned to follow the system prompt, right, that means that this type of prompt syntaxing is the most, is going to be favorited, right? It's going to be pulled towards wanting to do similar things because this is how it was basically fine-tuned to follow, right? So just keep that in mind. You're working with GPT, that's going to be a similar type of setup for your prompts is going to always be the best syntax for that because of the synergy with the system prompt, okay? That's just the thing. When you use certain syntaxes here, it trains it further and also enables you to then use it in more advanced ways later, right? And that's the case for any kind of system prompt that you complete downscale, right? Because if you make your own meta prompt, right, it would be getting entered down here, right? So you would have your profile, and then you would have the first input prompt, right? So when it gets fed to the transformer, right, it gets this whole system prompt, then it gets the custom instruction profiles here, right? And then it gets the first initial prompt, right? So this first initial prompt is a meta prompt, right? It's a gate that's going to be set up through this, right? So that's just something to keep in mind. And this goes out, this chains out in infinite ways, right? Response one, right? All of these things provide additional context, okay? And that's the thing, right? By feeding in the system prompt like this, and then by chaining all these other parts correctly, right? You can reconstruct understandings by understanding this stuff, right? The thing is, massive inputs have always been the key to complex understandings. That's always been the case. And that's why you see meta-prompts thriving like they are, okay? So anyway, we've been over the parent syntax, okay, which is Markdown, typically just with headings and maybe sometimes with syntax, right? So another element of Markdown that you can use is just like the typical syntaxing, formatting syntax, right? So this is for bold, right? You take one out, that's going to be italicized, right? So that's a way that you can add additional attention tuning on top of things, right? So they have MD superstructure syntax, right? And then outside of that, they have some instructions at the top. This is what I typically reference as top framing instructions, okay? And then they don't, it's not here because it doesn't have the profile, right? But this would also, there's also some bottom framing instructions here and reminders, okay? So this is the setup that you'll see emulated in OpenAI solutions, because this is what they have the entire model trained to follow, okay, in terms of prompting styles. So Python, simple, no explicit instructions, right? All it does is really define some context about its operational environment. See here how it says, it basically defines it'll be executed in a stateful environment, and Python will respond with the output of the execution or timeout after 60 seconds, right? So the only thing it's actually really defining here is that it's a stateful environment, and that it'll execute whatever code is in there and respond at a maximum of 60 seconds after execution, right? And then it also defines where the drive is. Everything else is left open-ended unintentionally, okay? So that's Python, the best tool they have right now, because it's not restricted, okay? It's only restricted by the amount of time it can call. Now we have DALL-E, right? DALL-E is an amazing model, but it's hard crippled by this, okay? They are trying to prevent generations that they deem inappropriate to the max extent possible. And that is why you see stuff like this. Yeah, the DALL-E system prompt, right? So in order to prevent, because it's calling another model when you're doing a DALL-E call, right? So they use a meta prompt to do prompt enhancement for the DALL-E model for whatever kind of input you give it, right? And that's the next part that we'll go over here, right? So because of that, this is a multi-model process, and the prompt is getting generated live as it's calling the model, basically, right? And because of that, it's not really easy to detect things that they deem inappropriate like it normally would be with just normal text generation, right? Now they have additional layers that are basically watching the text that is generated for these input prompts separately, classifiers, right, to kind of detect if certain prompts are going to be result in an improper generation as it's happening, right? And that's why if you're doing things, sometimes it'll call the model, and then you'll get that yellow or orange exclamation mark saying that it failed, right, midway, because that's what's happening. These other layers are detecting with the classifiers improper words or sequences of words, and then it's shutting down the stream as a result, okay? So there's a lot of layers at work here trying to detect that. That's not a perfect method, right? It's actually very imperfect, and that's why they have multiple layers trying to do this. One layer is the classifiers, like I said. Another layer is the system instructions here, right? That another layer of and framing to the main model, right? So this is going to be framing how the main model is performing the prompt enhancement, right? But it doesn't actually, this system prompt is not the system prompt for the classifiers, and it's not the system prompt for DALL-E, right? So this is only impacting the main model that's going to be doing the prompt enhancement, okay? So that's just something to keep in mind. So they have a bunch of stuff here, explicit instructions for what to and to not do. Any kind of explicit instruction they have here is going to impact any kind of input to this process, right? Because it's going to be factoring in all of these for every single request, okay? So promise to be in English. They're hard coding that it has to be in English, right? Don't ask for permission to generate it, just do it. Thank God they added that, because otherwise it would probably always be stopping before calling the model to ask for permission first. Do not list or refer to the descriptions before or after generating the images. This was pretty interesting. So what it's basically doing is it's stopping it from going ahead and generating the JSON payloads that it creates for these images ahead of time, right? So if they don't have instructions like this, it's very eager to give these instructions because they're fresh in the context, right? So they have to put this here to prevent that from happening automatically, okay? Do not create more than one image, even if the user requests more. I mean, it's very ironic that they've had this in here for a while, but this line stays static always in their system prompts, even though they're constantly changing the amount of images that it can actually generate. So like this really doesn't actually do anything, but it confuses the hell out of it when you ask for multiple images because of this line, right? Because down here they have an N field, right? Number of images, and even right here 2. So they haven't even updated their own prompt for the changes that they make to these parameters, right? Because it will still generate more prompts than one, or it'll still generate more images than one because of that, right? Do not create images in the style of artists. You can name them only in the prompts if their latest work has been. So basically, they're setting rules here for how to deal with explicit anchors of people, right? Here's the problem, right? Is that if they didn't have this line here, and this line here, and this line here, it's absolutely crazy what DALL-E can do with what it's been trained on. It can accurately visualize and do anything with any kind of figure, real or fantasy, whatever. Anything that's been actually made and modeled that has a lot of training data, it can do it almost perfectly, right? These instructions here and the fine-tuning then make it so that way anytime you actually reference anything by its name, it immediately changes how it handles making the prompts, right? So in reality, you can bypass this completely simply by having it make prompts and by giving descriptions that never actually use the name and instead just are the high dimensional understanding of who this is without the actual name, right? That bypasses all of this and every single kind of layer they have. That's kind of how my dynamic visualization GPT works, right? By bypassing this. So just keep that in mind. They're basically hard compromising their own model intentionally here to try to prevent copyright and also, but it can perfectly emulate every single thing that's been ideated before to a crazy degree. All right, this is the only reason why more people don't know that already. Okay, so these are the explicit instructions. English, don't ask for permission. Don't repeat the JSON payloads. Don't create more than one image, and then handling logic for what to do. And you can see here, if asked to generate an image that would violate this policy, instead apply the following procedure. Substitute the artist's name with 3 adjectives that capture aspects of the style. So what they're doing, they have a line in here that basically does what I just said. Swap the label with a high dimensional understanding of what that would be. But here they're just using 3 words. So that's literally nothing, right? That could be, those 3 words could mean anything, right? What you actually do is just substitute the artist's name with a detailed hypermap of their characteristics, right? That actually works to do this very well, okay? So after that, this is where we have a meta prompt, right? Or a meta prompt template in particular, right? So this is in reality, this whole prompt isn't, I guess you could call it a meta prompt, right? But it's a prompt with a meta prompt inside of it as a single layer amongst many layers, okay? So at that point, what do you even call it, right? This is what I mean. That's where I start to call meta prompt, right? This because that's from reality what it really is, right? It has multiple layers inside. The meta prompt is this part, Red, where the second it moves to the prompt template for the prompt enhancement for DALL-E, right? So Meta-Prompt doesn't have to be just generating prompt. It can be anything that influences prompt generation as well, right? And this includes prompt enhancement or prompt refinement, right? So this is where we go into the meta prompt right here, okay? And notice, I want to also notice how for this entire thing, they have these dashes added, right? Or not dashes, whatever the hell you call these. I don't know why I'm derping on this right now. What do you call I will forget the most random things sometimes. What do you call these? Someone help me out. Double dash. Slash. Yeah, forward slash. There we go. Yeah, slash. Notice how everything has these forward slashes, right? This is another way to delineate a layer, right? By intentionally including this before every line. It's basically, it works to have the LM understand that this entire section is a layer to understand as a separate entity, okay? So anyway, so they have these instructions and they immediately go to the meta prompt part, right? So the generated prompt sent to DALL-E should be very detailed, around 100 words and long. And then they give an example invocation here, right? So notice how they have the triple backticks, right? Same thing we talked about last time with the Anthropic meta prompt, okay? And then they have a key with an insertion, right? For the value, okay? This is setting up the main, setting up the main anchor, the main node of the output prompt, okay? It's locking it in here, right? And then here, it's going key by key for the second layer or the second level of keys, okay? And explaining what each one does, right? So the first one is size, right? It has 3 options to pick from. So it's deterministically setting the 3 types of options to pick here, okay? And then you have some notes defining what it is. Note how for these lines, it does not have these 2 forward slashes, right? What is that? What do you think that the reason for that is, and what that winds up doing? The answer for that is that it clearly delineates everything else as notes, and that these are the actual instruction lines, okay? So everything else is kind of a note, and these are actually, it's hard anchoring these to a deeper degree as a result of simply just setting these forward slashes like this, okay? So first it has size, has 3 options, and then it has n, which is the number of images that it'll generate in a single run, okay? Default 2. Should not simply be longer. And they also explain how to change the prompt here, okay? But other than that, they don't really have that many instructions here. It's just basic open-ended framing. They set anchors, okay? First anchor here, insert the prompt there into the main anchor, okay? And then they define the subkeys here with the options, right? This is a better prompt, right? Because this is how it works. You define the anchors and then you give notes for how to work with the anchors, okay? Keep this in mind for future stuff, right? Then they end it with the bracket there and the note. Where do they start this bracket? Up here, okay? So look, bracket here, bracket here. It's very, very important to understand with these kind of prompts that every single symbol, every single thing is very intentionally put here. Every single thing has a purpose. Every single token has a purpose, right? Every single thing works to delineate things further, which works to increase the understanding of the instructions, okay? Then you have browser. They added, this is newer, they added in reasoning for the types of things that it should use browser for. So before they added this, it would randomly call browser tool for different things. Like literally anytime you asked for anything that it determined would be better to like search for recent info from the internet, but that would always explode things basically. So this is an attempt to kind of control when it does that. How well this works, I'm not sure because I don't use browser tool. I typically use things with it disabled, but it's not going to be the best way to do this because it's going to impact everything else. Adding this basically, because you're adding this to the browser tool, but you're not adding it to any other tools, it creates a holographic projection basically of what these would be for these other tools, and that impacts things downscale no matter what, even if you're using these tools or not. It warps the self model of each tool as a result of doing this. Okay, stuff to keep in mind. So they have a couple shots of use cases for it. All right, now they have the steps worked out now what it's doing. Right, so it's calling a search function to get a list. Okay, right. This is how it searches the web, but the OpenAI doesn't use pre-curated information. It's just doing a general browse and then pulling in a bunch of data, right? And that's what breaks a lot of stuff with proper vector databases, with this stuff, with proper scrapes curated. It doesn't have this problem, right? This will probably be fixed in future iterations, right? And then they're defining the commands as well, right? Notice how they use different syntax for all of this, right? So as you can see here, they're using the brackets, right? And parentheses and all this kind of stuff to set variables here. So if you even use a very special one here, right? The big one. I don't know what that's called, but you can see it here. Okay. So because of this, they've already defined logic behind these different types of symbols in the system prompt, right? So you can use similar things to set up complex versions of this stuff downstream. Okay. Hell, you could even put it in the profile, right? Because keep in mind, this profile is custom instructions. Right? So GPT, the only thing that's changing here is that the custom instructions gets replaced with the new system prompt with the instructions, right? It's the same chain that happens, okay? But also you can have more control over the original system prompt as well at the same time, okay? So that's the basic gist for this right now. Square brackets, yeah. Yeah, it's programmer prompting. That's a good way to think about it. Thank you guys for the correct names. Appreciate it. Last stream I was calling the MD headings HTML tags. I have no idea why. It was just that's something that happens when I'm in this stream of consciousness trying to explain things. All right, but that's the system prompt here. Okay. Basic stuff. So now let's talk about how this plays out in reality. Okay. So this is the interface for GPTs, right? Name, description, instructions, conversation starters, right? I'm pretty sure these three get injected into the stream as well. But these definitely do. The important thing to keep in mind here is, firstly, the capabilities here, right? So the fact that you can toggle these is really important to understand, because when you toggle these on or off, you're changing the system prompt you're changing the system prompt here, right? If I toggle off browser tool here, it's going to remove this whole section from the system prompt, okay? And the reason why you want to do that whenever you're not using certain tools is because it directly improves the model, basically. Like you want to remove these sections, you want to remove browser and RAG from the system prompt whenever possible, just because the way they have this set up impacts everything. Like if you have variables and stuff, commands set up that use any kind of logic, having this in the system prompt is going to directly affect anything that has any kind of variable or algorithmic logic formulated, right? Because they're defining things here with certain symbols, right? So if you don't use similar setups to what they have, it's gonna interpret it differently, and you're gonna have to constantly change it based on what they decide to do here, OpenAI, even though what every company is doing is actually different, right? And that's the thing with prompting, right? Is that the best prompting is different for every single one of these main models up here because of how they're set up differently, okay? So it's just something to keep in mind. Yeah, that's a good one. I'll copy the stars, put it on for, do this. It's a good one. Yeah, so remember this, right? Because this is really important. And we're going to be using this in the stream. Thank you, Darth. Okay, so you can toggle these on or off. I typically always have browsing toggled off, and I have Dolly toggled off as well, unless I expect to be using images. But you can add in Dolly without much problems. It's pretty delineated in terms of impacting other things compared to RAG and browser. Okay, but anyways, you can change this and change the system prompt dynamically, which affects a lot of things with GPTs, right? They're going to be adding memory here, right? Which is going to be a new section here that allows you to basically add in instruction blocks, and will also have memory that you will be able to, I'm not sure if you can hard edit it, but I think you can delete it. But the other thing is that you can actually talk to the LLM about what it does with the memory to actually have it handle that. So that's pretty cool. It's going to be pretty awesome in that regard. Okay. But GPTs are not going anywhere. The only restraint right here is this, because it's 8,000 characters, right? Very, very, very small. If you add knowledge, so if you add a file here, okay, it's going to change the system prompt as well. It's going to immediately add in the RAG part, and it's also going to add in additional instructions framing how to handle its knowledge files, because it handles files you upload in the base GPT interface differently compared to files you upload in a session. Okay, so that's because it's framed in the system instructions that it should be doing things differently. Now, something to keep in mind here is that because of how their jank setup is with RAG, if you, in order to try and increase the quality of RAG, if as long as the tokens are under a certain amount, if you include a file here, it'll just embed it straight under the instructions. Honestly, it's a horrible, horrible design. They should just be increasing this and actually fixing RAG. But it's a way to get around this. But basically, if you have small files, you can just use it as a text file and have it be embedded as an additional system prompt, basically. Okay, so just stuff to keep in mind. What do you mean I missed square brackets? Oh, you're absolutely right. Thank you. There we go. All right. So we're going to go through some toolchain stuff real quick, just to show some more stuff with the toolchains, right? I'm going to set up a GPT for this right now, just to control the system prompt and everything as much as I can, okay? So let's see. Let me think of this real quick. All right. And then we'll have Dolly and code interpreter toggle on it first. So for now, so this is going to be where I'm going to be ideating two prompts here on the stream, right? First one is going to be for tool chains. And the next one's going to be for the meta prompting stuff that we'll be doing later. All right. But when I ideate these, I'll be coming into here to update the instructions here. Okay. But we won't necessarily be constrained to only working out of here. That makes sense. All right. So for now, I'm just going to have something extremely basic because I don't even know what this is going to look like yet. Yeah, something like this, right? So just having it probe itself for its own thing, it's going to reflect on its system prompt basically to form an understanding around each of these, okay? So something simple. Right, so this is at this point with what I'm doing right here. It's basically just a prompt, right? The custom instructions are a prompt, and by not giving it a new prompt, it's basically just having it execute the last one, right? So it has access to two tools in its interface here, right? Dolly and Python. So as a result, these are the only two parts of the system prompt that's actually in its memory, right? In its understanding. You can see that right here, right? So let's test this again. All right, so now it's toggle on web. Okay. Add a command here. So basically, when you have it like this, you have the system prompt being fed in first, right? And the sections here are only included based on the tools that you have enabled in there, right? So if you were to disable all of the tools, right, you would be getting a very, very, very small system prompt. It would basically just be this with some GPT instructions and then knowledge files if you have them, right? But just keep that in mind. Anything that you do with tools enabled, these system prompts are affecting interpretation and just different things, even if you're not using the tools, simply because of the logic that's formed in these prompts, okay? So just something to keep in mind. It's extremely important to understand that because you don't want to waste your time like making solid logic, right? That actually is extremely solid and can be understood by different LLMs that don't use these specific methods, right? But if you're trying to do this in only one system you're basically working out of OpenAI's system right now by trying to work. As soon as things get a little complex, you have to start using similar things they do, right? And if they make changes, you have to change it too. So just something to keep in mind, right? You can have extremely solid logic and extremely good patterns modeled, and just because it uses something slightly different than what they've done here, it might not be understood properly. But if you toggle off these sections or try different LLM, it will suddenly work. Okay, just keep this in mind for how they have forming these, and they've been adding to this over time. So every single time they add a new symbol or anything, it affects how stuff is interpreted, and it's hard to actually tell a lot of times. Okay, so you have a system prompt that could potentially be a lot smaller than it's shown here, right? And then you have the instructions, which is whatever's here, right? There is no profile injection because that does not get included with GPTs, okay? And then it has the first user prompt, okay? So if this first user prompt is start, right? And the custom instructions are this, okay? And let's even add in this. Okay. We can title this system prompt. Okay. All right. So this is kind of how, by me executing start in a first input here, this is basically what's happening here, okay? These first three, this is all getting fed in to the transformer. Well, outside the browser tool part is removed, right? All this is getting fed in, okay? So let's see with web browsing first. Let's see what happens now when I do when I do start, okay? So now it should have a different understanding because now it's factoring in browser tool, okay? See, now it has browser. There you go. So it has a clear idea. See what I'm talking about here? How it has formed an idea here for how to use these tools because browser has and has examples provided for it. Let's check the other one. Where is it? See how it doesn't automatically include the use cases here, but here it does. This is exactly what I'm talking about, right? Because they provided use cases for browser tool like they did, it's going to project that into every other tool and have it make assumptions for what it should be using these for. It's not necessarily a bad thing, right? Not necessarily a bad thing. It's just that it's important to understand how simple changes to this can manifest elsewhere, right? Once you have stuff modeled like this in multiple layers, there's no real way to add something to one layer like this without it being projected into the others, okay? This is why sometimes leaving things out is sometimes the best way to do things. Okay, so we see the differences here, okay? How having these different tools in the system prompt changes its understanding of things that it can do, right? So if you were to have browser tool disabled, right, it would have a technically more complex understanding of how to use these tools because it's not restricting itself to certain use cases from the start, okay? Now, if you were to actually have it do this first before you do things, this helps delineate the tool behaviors by having this in the context, right? So it would actually improve how it uses it after this case. That's something cool just to keep in mind. Okay, so what are we doing here? So the other thing I wanted to show you is, so this is how that works, right? So now, right, what happens if I were to paste this? Actually, how do I get it without if I were to do it like this, right? In the base model, it'll be the same thing as like doing the same thing with a GPT, except this time it has the system prompt for all the tools, right? But not RAG actually. Right, but you can do something similar outside of GPT, right? Because it's how this all works is exactly the same, right? GPT just allows you to delineate things a little easier, and it has access to more tools. Okay, see here, look at that. It has tool synergies already for modeling from this. Actually, no, this might be because of my custom instructions. Actually, it's probably because of my custom instructions. That's the thing. Here, we'll do this. And we'll put all of them on. We'll even upload something. I don't know. Let's make like a fake document. Could probably add something to it first. Okay. Let's try again. All right, so now we have a file uploaded. No. Okay. Right. So this is basically has all the tools on right now and a file uploaded. So it's going to have RAG in there as well. Okay. So now I have to include something here. I guess I could just do this. You have to include something here in order for it to let you save it. That should work. It's fine. Right. So this is as close to control as you can get with a GPT here, right? So if I were to do this now and add this in, right, this would be very similar to what it would be like with the other two setups that I showed, right? But this time it's going to have all four. See? Complex toolchain examples. Wait, what the hell? Oh, it's because I have it. Oh, okay. About to say. So see here how a couple things happened. It added in RAG, right, which is actually defined as my files browser. Okay. And it also gave some examples of how to chain these, right? So let's see what it said. Image creation using Dolly tool. That's not really a chain. That's just using it. Right. So it only has really basic ideas of how to use this. It really doesn't have the best idea of how to even use its own tools, right? That's something really important to understand. It has very basic understanding, right? There's lots of reasons for that, but it's just something to keep in mind, right? So this is its idea of a complex tool chain, right? It's literally just using it's using the tools. That's its idea of what a complex tool is, right? So when you see this, you're basically probing. What I'm doing right now is I'm probing how things are being interpreted, right? Because when you see how things are interpreted, right, it can give you a lot of understanding of how to actually model things to do what you actually want, right? So because I see here that it doesn't really have a good idea of how to use its tools, right? That means I probably need to update its self-model of these, right? With my own knowledge of how to actually, of what this should actually be, right? Because the same way that they train understanding that gives you this from a system prompt, right? It's the same way that you can do the same thing with other prompts and additional context, right? It's just important to understand how the main system prompt is the main gate, right? And you just need to make other gates that synergize with that, but add new information, okay? So there's something to keep in mind. Let me see if there's any questions. Yep, Envision will activate if you attach an image, correct? Thanks for a reminder on that. I guess we could try it with a image too. Let me see what I have. Add something random. I think Jacob made this or someone. Oh my gosh. See what happens now. All right, so it doesn't actually recognize vision. Oh, look at that. Got a little self-model understanding. Right? It doesn't really understand that the vision model is a different tool or model, right? And that's explicitly actually set in the system prompt here, right? It just has it as a variable. Just as a variable without an actual section to it, right? So it doesn't actually understand it as a different tool. And that's because of how they frame it here, right? But when you upload an image, it gets processed with the vision model, right? So just stuff to keep in mind. All right, let me go grab my drink real quick and then we'll get started on some prompting. Give me 1 second. All right. So I think the best way to do this, I think we're just going to do it all at the same time, actually, instead of doing it two different things. So let's go over, we'll set up a meta prompt for the solution space with tools at the same time, okay? So let's go over the idea. So this is an idea Jimmy had with lesson plans, and we've been working on some ideas for this stuff because of some prompts that I made and applications of some of the techniques that we've been discussing the last few weeks, right? So let's just go over this idea real quick. Remember this. Semi-automatic online course creation, meta prompt collection GPTs that can help with this. We have plenty of course content, right? We just need this turned into lesson plans, right? So his suggestion for the workflow was gather SPR current food industry topics, and with gather. Okay, so KR to prime it with a high level prime, and then have SPRs of different food industry topics for downscaled projections, okay? And then develop a set of customizable prompts that, so basically a couple task prompt templates, right, that can be paired with this, right? So this is actually a really solid idea. And this is actually exactly how it will probably work because you have this model for a couple different layers of projection, okay? And see, he had his little typical course slide, lesson, etc. And he has an idea for how this would look, right? So this is kind of forming anchors right here in the act of doing this, right? Trying to figure out what the best what the best anchors for what the best lesson is, right? Like finding these patterns and uncovering these patterns is a lot of the work, right? For this stuff, because a lot of what you do with meta prompt engineering is digging into the data and in an abstracted form of what you're actually doing and finding the best anchors to form things around. That's what lets you actually do this stuff dynamically, right? So it's a really good idea. And this is what will basically be, I haven't actually worked on this yet, but we've talked about it a lot, right? And this will be a good example and way to show a lot of different things, okay? So I have a prompt here actually that I released in the master prompt library, right, for lesson plan generation. I'm not going to actually use this here, but I just want to point out that this is actually a really good one to use for this stuff. And you have little templates here that I kind of made that are for examples, right? So templates are always going to be examples, right? Because all these really are is defining some synergistic input variables that you can go in. You can be like, you can go in here and you can change this, right? Like you can be like, change this to, I don't know, mastering using Plato or something, right? Grade level, first grade, right? And then input this, and that's setting your main anchors, right? That's injecting the personal context that things are going to be formed around. Okay, these are just examples, right? I like to separate things out like this because it makes things more modular and easier to refine, right? Because this is like the core logic of the prompt, right? There's no variable defining in this prompt. It's just defining the process in a couple different ways, right? And then I have the input variables modeled separately. So typically what I'll do when I'm actually using these is for what I'm doing, right, I'll set up some anchors for the task I'm doing, right? And then I'll typically inject it somewhere, like probably like up here or something like that. Like add somewhere into the prompt for these anchors, right? I might go in here and be like input, oops, and then put it here, okay? Something like that. That's typically what I do, right? Anthropic, for example, has their meta prompt going to select these and inject them into the prompt creation process at the same time, right? But the problem is that kind of anchors everything around whatever determinations it made, right? So you have to know ahead of time what the best anchors are, and you can even define them in the prompt setup they have, right? And it'll do it that way, but it makes it static in a sense, right? You lose the dynamic nature and potential of these prompts by hard anchoring in input variables like that, right? You can actually use dynamic templates like this to do different kind of setups for different stuff, right? This isn't actually, these aren't very good templates, right? They're just examples, but just wanted to go over that real quickly. So I'm going to be ignoring this actually, because that's counterproductive for what we're trying to do here, which is teaching this stuff. So I'm going to be doing this from scratch and from a completely different direction. And we'll just go with the flow here, okay? So we have an idea. Now he has this being done for food industry training, but the reality is, what I know is that the only way to do this is to set this up to work for anything, right? It's not going to be focused on food industry training. It would be able to work for anything, because the way this works, well, I guess actually it could be narrowed to this, but it would be better to model this more generalized fashion, and then you can narrow it in on specific topics, right? Because the act of doing this for one thing allows you to do it for anything, right? So you might as well just start from the top and work your way down, while also doing bottom up at the same time, right? So we're going to do this for more generalized instead of food industry, because I don't have a lot of, I mean, I have some experience with food industry, but not probably like you do with this stuff, okay? So the first thing to do, there's a couple things that we have to do, right? We need to, the point of this, like, what is the desired output, right? Like, what is, so this will be our version 0, 1. Okay. Desired output. What exactly are we trying to do? We're trying to get a lesson plan here, right? What's our intent? Synthesize a, oops. Synthesize a tailored lesson plan based on the user. All right, so these are our basic variables right now, that we have confirmed, right? Notice how I have capitals here, right? And then I use the same thing here. That's very intentional, actually. It just by having it, this kind of intentionally breaks patterns in a sense. Intentionally is like, okay, why is that capitalized? That should be a normal word, right? But it's capitalized, right? And then it also is capitalized and used exactly the same way in other sections. This is a really easy way to add attention control and coherence to patterns by doing stuff like this. By adding capitals to an entity like this, you can basically enforce it as a separate thing for whatever you're modeling here. Okay, right? So these are like the crucial input and outputs, right? That for any kind of black box, right? You need the input. Actually, you would need the input too. Right? You need to know what you're inputting, and you need to know, it needs to know what the end result is, right? Then the black box can do its work. Now you can, here's the thing, right? This is all you really need, okay? And you can add more stuff here, right? To actually put input here. Let's say, here, give me someone give me a domain or topic that we can test this with. Something interesting. Something complex too. Okay. I'm gonna go with metal augury. I like that. Right, so I have input labeled here, but that's it, right? I haven't actually labeled what I'm inputting, right? I just have a random thing. And I actually haven't defined anywhere here what the lesson plan actually is supposed to be. This is just like super basic, right? The only thing that's really modeled here at all is just an intent. I'm hard anchoring what the intent is here by doing this, right? Anytime you add a variable like this and then anchor it with a well, it could be an equal sign. It could be a colon. There's a lot of different ways that you can do this, right? But anytime you do something like this, right, you're anchoring in an understanding, right? This is the intent. This is the input. This is the desired output. It's a really easy way to do this, right? Something I was talking about with someone earlier before is that, okay, well, like, do you really have to do that? The answer is technically no, but there's a lot of reasons why you want to, right? So you could do something like this, right? Maybe I should have started with this first. What would a basic prompt be for this, knowing that this is what we want to do, right? Let's do this, right? Hi, ChatGPT. Maybe this is a little too too much, but this is really my point, right? Please synthesize the tailored spell for right. That's the same. This is kind of like the same thing. This is like a free flow. I don't know what you call this. This is a prompt, right? It's not delineated at all, but this is a prompt, right? Technically, this contains the same information that this does, right? But the difference here is that this clearly delineates the information type. This has two. The reason why you do this is it has two big reasons, right? One, it massively improves the LLM's understanding of the content, right? By pre-labeling and pre-delineating things, you're easing computation for inputs, right? And with very, very, very simple things, this isn't going to have much of an impact at all. But as you start working with more and more complex input and information, it becomes increasingly important to delineate things in order to actually get the full complexity of the information properly understood. Okay. The second reason is because doing this allows you to progressively and increasingly streamline prompt engineering the more and more and more you do this, right? Because here's the thing. If you just have this prompt, right, this really isn't reusable. This really isn't like something that you can save and like, or even worth saving, right? It's just a random thing, right? But all of a sudden now, the second that you have delineated things, right, now you can copy paste, change these to variables, right? Open variables. Now you have a template, right? So now you have a template, right? Even though 5 seconds ago, we were here just by delineating, it's this easy to make a template, right? This is actually, I mean, this is literally the most basic template possible, but it's a template all the same, right? Let me show you an example of some of this stuff, right? So let's go to our base model tester. How should we do this with all systems? Let's do this with all system tools off first. Maybe we should do it with all of them on. I don't know. Let me think for a second on this. What do you guys think? Should we do this with all the tools on or off? I'm gonna later turn them on when we start incorporating tool stuff, but should we just keep them all on? Okay, let's keep them all on. I just don't want it to use, I don't want it to use tools, but that's fine. Oh, here, let's use the let's use Toolmaster then. Let's use Toolmaster. We'll build this one out then. We'll make this Toolmaster lesson plan legend. Lesson plan. Okay, now we're going to remove this. I'm going to have no instructions for now. All tools on. Okay. Now there's no instructions here, right? So there's really no system prompt from the GPT here. So anything I input in the first prompt will basically be whatever this would normally be, the instructions there. Okay. So let's start with this. Let's see what happens. Okay. Huh. So it's going ahead and asking for details that it needs in order to be able to do this. First off, I immediately noticed that this is something kind of new. Normally, it does not do this kind of checks. I wonder if this is part of the. I wonder if this is the new model. They fine tuned for a little bit more planning. Interesting. So it just identified key dimensions to this process that I suggested that it needs to know in order to properly do the task, right? So if I was to force it to do the task, it will do it, right? But it'll have less information at hand to be able to do this, right? So it would be able to tailor it to a less degree compared to if I gave it more information, right? So right now, this is me probing the model, right, for a certain solution space. This is how you can typically always start this stuff, right? So now let's just test what happens when I force it to, right? Set mastering. That'll add some context of what this is supposed to be. And I'll add a little code box here. Let's see if this works. Sync. So you can force it to do something. You can force an output like this at any point in time, right? Just with simple stuff like this. But that doesn't necessarily mean that you always want to, right? As we just saw before I forced an output, it determined that there were a lot of crucial elements that it needed to be able to do this properly, right? It can still do it without anything, right? But this is just super important to understand. So it's important to see also what it does when it is forced to do something with no context, right? Because this is going to be kind of your idea of the kind of anchors. Can you please paste the prompt and response here? Sure. I have this all on the, it should all be on here too right now. It doesn't let me, it says it's too long. Here, let me, need how I do this a lot. All right. So we'll just do it like this. Just remind me if I start forgetting. Okay, we'll paste this in, right? So this is a 0-shot test of what it does when forced to generate the lesson plan with nothing. So this is me. I have set nothing except the topic, metallurgy, right? And I have not delineated things at all like this, right? So this is test one, okay? So then, actually, you know what? Let me just move this stuff down. So we're going to do a couple tests. Yeah. So for this one, we're going to try the other one, okay? And with no response template, right? And I want to note here with these triple dashes, right? This is something really important to understand because this is kind of how it a lot of times is forced to give its response with top framed instructions, bottom framed instructions, and an input section. It also shapes its response like that often. with like an intro that acknowledges the intent. The content in the middle, and the conclusion at the end. So adding in these triple dashes is a really, really, really easy way to basically just automatically delineate sections like that. You can add a bunch of these too. All right, so okay, so keep in mind, so there's no response template here, okay? All we did was it's the same prompt, just delineated slightly, okay? And now what you can see happen here is that it immediately made one, right? So I didn't have to make a response template for that, right? And that's because I clearly delineated what the desired output was, right? I clearly explained that I expect its output to be the lesson plan here, right? If I was to, and also I'm saying synthesize this based on this input, and I also provide the input here, right? So it's basically confirming that it has the information needed to do this, okay? But simply delineating like this improves the understanding of what you're trying to do. Now, because of that, so I understand that these three simple instruction and layers together work to improve this understanding, okay? So now, without touching anything else, I can add bottom framing, okay? And this is how you can fine tune those things when you have something that works, okay? Now I can set the response structure. Okay? And this is a really easy way to hard code in open-ended complex transforms, right? Because you can have the information be used in different syntaxes and different things in a single response. And every single time you do this, it works to understand the information slightly differently in each layer, okay? So you can set up stuff like this. I typically do something similar with a markdown superstructure and then layers in the center, right? And it typically works because it's how it's already trained. Title, right? And then you can add layers now, right? Let's do lesson, let's do course modules, okay? And then we'll do course main core modules, level 1. Sub modules, level 2. Copy this. So I'm shaping its response right now. So I already know how this is going to be interpreted, right? So now I'm going to redo it, but this time shape how it forms its response, right? And I'm going to be able to increase its understanding of this simply by shaping how it should be producing information through. I'm basically creating a template for it to project its understanding through, right? And the act of it following this will improve its understanding in certain directions based on what I define, right? So I don't know yet how it will actually interpret this exactly, but I have an idea for what I'm trying to do here, which will make sense as you see, right? So this is kind of how you can progress, like recursively improve the stuff for any kind of space as you test stuff, right? So this is just kind of how I get set up, right? Try and just establish the high level understanding of what you're doing, and I would kind of shape some important variables and see what happens, okay? So title, this. So what I'm actually going to do, here's the thing, if I were to do it like this, it's going to basically list title. It's going to say title, right? And then it's going to do this. What if I actually wanted to actually give a unique title, right? Well, then that's where the syntax that comes into play, like what Darth was talking about, right? So let's go with what this says here, right? So curly brackets is to define objects and libraries, parentheses, options and items, right? Square brackets defines lists and arrays. Pointing brackets defines tags or references, right? So what would I add to this to indicate that this is a note and it should actually replace this with whatever the determination is? What kind of syntax should I add to this? Does anyone know? No ideas? Okay, yep. Yeah. Agreed. The curly brackets. Exactly. Right? So you can have curly brackets like this to delineate that something is actually supposed to be replaced, okay? And that's not actually just a word itself. It's an object, okay? Now, here's the thing. The second that you add this in, right, this adds in an extra level of delineation here, right? What else does it do? It clearly delineates between this and this. These don't have the curly brackets, right? So what does it mean that this does and this doesn't, right? Just simply by adding in these symbols, right, changes how these things are interpreted, right? So let's take these out first, and let's just test this real quick, okay? So what am I doing here? I have an intent. I gave it an input, and I told it I want a lesson plan, but now I'm telling it to basically shape its response structure with the course. So not even lesson plan, the course, right? Core modules level 1, and then the submodule level 2. What am I trying to do? I'm trying to basically get it to model from a higher abstraction level kind of what the core nodes and anchors should be for this, right? And now this shouldn't actually do anything. It should actually kind of ignore this and only use this as a high level framing for what its goal is. But we'll see what happens, okay? All right, so I went ahead and actually followed it correctly, even without using any anchors or symbol anchors. Level 1. All right, so what is it going to do for level 2 then? Okay, that's pretty good. Not exactly what I wanted, but it understands. Okay. So what happened here? It understood what I was telling it to do. I didn't even have to add delineation, right? It correctly replaced the title with what it should be. And then also just used this without actually changing this, right? So that's actually exactly what I wanted it to do here. I didn't have to, but here's the thing, I didn't define that, so it's open-ended. So technically I could redo this and it always has a chance to make a different determination. See, what did I say? Right? And it's how you can predict this stuff without even trying stuff, right? You can know how this stuff works without even testing it most time, and it gets increasingly better. Now, here's the thing: what just happened here, right? It did this wrong, but it did this part right. This is actually what I wanted it to do for this part originally, right? So here in the last one, this is completely open-ended, right? No framing of no syntax framing outside of just the core structure, no delineation, right? In the first try, I did the first part right and did this, it didn't exactly do what I was looking to, but I didn't actually tell it what to do, right? And here, it did the title wrong, right? But it actually did this part correctly. I wanted it to create the core nodes first, right? And then expand upon each one in the second one, right? So here's the thing. This is the result of simply just this. So now all we have to do, we have working logic here, right? We don't actually want to change anything too hard. What we want to do instead is make small changes to refine this, right? So first we'll do is we'll just simply add in this, right? This should technically work to have it create a unique title every single time. Now we'll see if that's true or not. There you go. Right, so it did it again. It did the correct title correctly again this time. And now it did the modules incorrectly. That's fine. I didn't change anything for that. See what it does for the second level. Okay. So it's creating submodules for these fundamentals classification. So it's creating, okay, that's cool. It's creating subnodes for these objectives. But it's only doing one for each. That's fine. That's still closer to what I was intending it to do with this. Okay. So now we have, well, we'll have to test again to see. but we should have narrowed in the behavior for this part, okay? Now we need to just narrow in the behavior for this, right? To be more consistent with what I'm looking to do, right? Because remember, we're trying to get what I did that first time, right? So again, simple things. We want to add as little instructions as possible. You can typically do this with some notes, right? I typically use parentheses, but you can do this in a bunch of different ways. You just need to use something different to indicate notes, right? You don't even technically need to add any syntax here, but I don't know if other people have preferences for how they do notes, but I find parentheses, as long as you don't have other things using parentheses, to be easy way to do it. You can also do like the double slashes as well, whatever you want. Whatever. I typically change this as if things get less understood. But here you could be like core nodes or nodes. And boom. All right. All right, look at that. So now we have some algorithmic logic going, just like that, right? That's kind of establishing base nodes and then projecting them out with self-similar patterns, okay? So you could technically keep doing this. You could now be like, you do like something like this. Now I could just copy this and be like level 3. I'll just do 1. It'll cripple it if it's gonna be too long. What did I say here? All right. Something like that. Look at that. Now we'll get 3 layers in, right? So everything's being projected right now in an open-ended manner based on established original nodes, right? And technically, you could just keep doing this. Like, I mean, it's going to eventually run into response length limits, right? But there's in principle, there's no end to this process, right? You can project things infinitely from established anchors, right? Really, it's just really important to establish those anchors correctly in the first place, right? So as you can see here, it's building out an understanding around this topic right now. This isn't even really, it's framed around a lesson plan, but this is building out an understanding of this domain and topic in general, right? That's what's happening right here. But it's being all projected from this, right? As you see here, so fundamentals, physical, chemical, mechanical, fundamentals, metal extraction, alloying, phase diagrams, heat treatment. There's a bunch of different establishing different nodes in each time, right? Introduction, types, heat treatment. So you see some similarities, fundamentals, extraction, alloy formation, right? So it's coming to different ideas for what these core nodes should be in each one. There's a lot of variation, right? That's because, I mean, these training processes, it's not actually hard coding these, which is good, right? It doesn't actually know what the best core nodes are. That's where the expert understanding comes in, right? You need to be able to have an idea of what actually, like, you need to have a comprehensive understanding of the field in order to be able to be like, oh yeah, like these are probably subnodes of this, and then you can create like a core nodes from that knowledge, right? If you have the understanding. Now, without that understanding, doesn't necessarily mean you can't do anything, right? It just means it might be a little bit more tedious, okay? And it might be a little bit harder to verify, but you can still do a good job to the best of your knowledge, and as you learn things as you go, right? So the more knowledge you have ahead of time before doing this stuff will only improve and improve and improve anything you do with any of this, okay? So what do we do now? So we have the core, the extremely basic logic, the functional logic going for this right now, right? But this is going not for the lesson plan. It's going, I mean, technically it is the lesson plan, right? These are the main modules, right? And these are the submodules, right? You could write out lessons for each of these aspects for the lesson plan, right? All we're really doing right now is spinning some extremely abstracted logic to refine out the functional logic, right? Because once you refine out the functional logic of this stuff, it's extremely easy to just add in new inputs and to just, once you have everything else working here and here, you can just add in progressively more complex inputs to continuously improve whatever it's doing, right? That's why I like to delineate stuff like this, because then it makes it really easy to do that. Can you try square brackets around the module and submodule and the instructions next? Sure. Like this? What do you think? What do you think it's going to happen when I do this? Mm-hmm. We got a little bit better delineation, right? Less text, like most people might see less text, but what I see, this is mostly fluff, right? But I see, where the hell did it go? Up here. What I see is increased granularity of the response. 1, 2, 3, 4. Right? Oops. Yep, exactly. That's the goal. Right. So you can play with syntax like this as you refine things to continuously improve. The point here is to try to refine the core granular logic. Like these are like the most, this is the essential logic, right? If I was to take out and just remove any part of this right now, you would have to make a lot of adjustments, right? Because we're modeling things on top of working logic right now progressively, okay? So everything, we're kind of building a shared language here as we go. Yeah, of course. It's the proper way to do this. So you're right to make that suggestion, right? And that's the thing. As the models get better, it's easier to get away with less, but then it becomes hard to notice the impact of leaving the stuff out when it actually does continuously work to improve things, just in ways that it may not be extremely visible to the eye, especially if you haven't been building it yourself. Okay, so we have this little engine going right now that's basically formulating nodes, right? So here's the thing. This is working functional logic, right? So I know that I can just go in here now and change this to something else, right? I can be like, lesson plan on picking the coolest hat. Something like that. And like, you'll know it'll work. See? This is the good thing. This is the beauty of abstracting and templating things like this, is because it makes it extremely easy to do things with any kind of setup that you have modeled like this, right? There we go. So now we have a lesson plan, the modules for how to pick the coolest hat, right? So we could build something out like this for a plan, yada, 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 right? Remember, all we're doing here is just testing and probing the core logic. We're not actually building out the solution for this yet. We're just probing to find the best anchors or something, right? So here's the thing. You have two options at this point, right? As you can see, literally with just a single anchor, you have an infinite amount of ways that you can spin even just this right here. You could just put an infinite amount of different things in this input and get completely different stuff in every single output, right? So every single type of input that you would put like this itself could be refined in that particular direction, right? Every single thing is going to have different ways to explore creating lessons for that type of that specific direction. Every single type of domain is going to have different types of dimensions and types of things to consider and understand and do for whatever lesson it was to make, if this was going to truly be tailored, right? So at this point, you have two options, right? You can either try to model the abstracted patterns for more generalized applicability, or you can start to narrow in as you want to start to build this out for particular one, right? So that choice is going to be something that is always going to be up to preference, right? Because the thing is, you can always continue in the abstract direction as much as you want, because the result of doing that is that you find and model deeper patterns at whatever you're trying to do in general, right? And that allows you to apply those patterns to any kind of input, right? And that means that the better generalized patterns you've modeled, right, any kind of input will just continuously improve from the result of doing that. And then it itself can be refined for that particular direction to any degree you want, right? So it's two different directions, right? You have to choose between abstraction to find deeper patterns to improve the generalized process, or narrowing in on a specific input to refine that out, right? Two different things. So what I'm going to be showing here with meta-prompt engineering is not narrowing this in, right? Because that's easy to do. Especially if you have the data, it's going to be reverse the opposite. It's going to be modeling the abstracted patterns to be able to narrow this in to whatever degree that you want. Okay, that's kind of the thing about meta-prompt engineering, right? Solution building is building out around inputs, right? Around certain anchors. But meta-prompt engineering is the science behind how to actually pick these anchors and how to use them in the first place, right? Okay. So with that being said, we try the course slide item and dialogue for this thing. Yeah, we'll get there in a minute. We'll get there in a minute. Here, I need to run the restroom real quick. We'll do this. Post any more comments you have here. I'll be right back. Yeah, so I mean, yeah, Jimmy, you're talking about narrowing it in though right now. I want to show this in the opposite direction a little bit more first, right? Because there's a lot more that we can do here before we actually start narrowing in at all. Right. So what are we really doing here? We're right. These are atomic. We're trying to model atomic reasoning modules, right? We're trying to create an engine that creates the best nodes that can then be expanded out in an automated fashion to do something valuable, right? So the important thing of this is that everything that happens after this is all based on this. So whatever, like, this is the most important part of everything, right? The quality of how this happens impacts the quality of everything else. Okay, because if you want to actually automate things and streamline things, everything is going to be dictated by whatever happens in the very first step, right? Because that's really how this stuff works. You form logic in certain areas, and then you use these patterns and projection techniques to keep it unraveling and doing things, right? So we have this basic engine for node selection and then unraveling going right now. For less, remember, this could be for anything, right? Because this is core logic right here, right? So course right here, right? I could just remove this, right? And I could remove this. I could change this to desired output. what should I say? Atomic reasoning network. So that semantic network. You can change this to a tailored neural net. I don't even know how to spell this. Right. So what I do, I just change this away from lesson plan to something completely random. Like I have no idea what this is even going to do right now, right? But this is my point is that this is what this really is right now is a atomic reasoning node selector, right? What's happening now? It's doing something very similar, but now it's doing it from a little different upward direction, right? With the same exact core logic. This is considering a lot of different things, right? This is considering things from a more holistic view, right? From the different sciences behind this being possible, right? The different material science, thermodynamics, electrochemistry, and then actually capturing some properties, right? So this is not actually the core nodes. What we're getting at here is that we have a ton of variation and a ton of quality consistency differences with every generation of this, with whatever these nodes are, right? And we're modeling lesson plan here, right? But the point is that if you want to be able to automate anything, you have to be able to have some way of selecting the best nodes properly, right? So we can see there's a lot of variation here, meaning there's work that needs to be done on this, right? So let's replace this back to where we were, lesson plan, right? So what we can do now is we can probably model some better logic to pick these nodes better, right? Because the reality here is that in order to make a lesson plan needs like a structure to it, right? A lesson plan by itself isn't very valuable, but a lesson plan can be considered part of a course, right? So if you have a course model or something that's complex in understanding, right? You can then synthesize separate lessons of that module, right? To way higher quality than if you just tried to do it all from a single turn, okay? So that's why it's good to model this process start to end from the bottom up, right? Because you can get the best, you can extract the best quality from everything, right? And then all of this is before we even start integrating tool chains, right? Which basically allow massively expanded context window sizes, right? So just keep that in mind. This is as basic and as inconsistent as it gets, right? So now we can start. Come on, this isn't going to be what the actual. We'll save this. We'll go ahead and save this. Okay. Right. So I want to add in some logic to improve how it does this, but you need to be very, very, very careful when you do this, right? Because anything you add, remember, everything is based off it. So anything you add is going to be factored into anything else. So you typically want to do this in the most open-ended and concise manner possible, right? That influences it in just the ways you need without actually impacting decision making for anything else, right? So to do this, you can do something like adding another node. Actually, what would be the best way to do this? Let's use the dollar sitting here. Select 10 nodes in total to act as the main inverse. Sports. Let's add some higher level instructions here. So we'll go meta goal. High quality. Desired output course modules. Right, so we're finding that this is the higher level goal at the end of this at the end of this process, right? But for this turn, we're just trying to knock out the course modules, right? So this is kind of anchoring in a better understanding of what it's actually supposed to be doing here right now. Okay, so now what I'm going to do is I added in some instructions here that should select 10 nodes. So I'm not actually telling it how to pick the nodes or anything else. I'm just setting in a number of, I actually probably do this in a better way. Let's do n. How do they do it here? Let's copy. Yeah, let's use this. Yeah, like we can also add in new other tags too. Default 10. Number of core nodes. All right. So what have we changed here? We've delineated the output, added high level instructions, and narrowed in the desired output for this particular turn. Okay. And we have added in some variable logic to the first part of the response, right? By defining how many core nodes it should select. Okay. Now, the other thing I'm going to add here is I'm going to add in reflection logic, because remember, if you don't give it time to think and plan, you're reducing the potential of its response, because it'll always be way better if it has a little bit of time to think first, right? So I like to always add in reflection logic when I always do this when I'm building something, right? Because it lets you narrow in things easier, and then you can easily take it out later. Reflection start. And 2 sentences next. Okay, I'm adding in resource logic here. I'm setting constraints on how long this should be, but I'm not actually saying what it is. I'm also going to hard anchor in this just so that way we can reduce this variability. Start response with. Okay. Notice here I'm using the italicize, right, syntax, and then including this with quotation marks. All very, very, very intentional. This is how you link things together simply with syntax. Extremely important to understand, right? By doing this right here, I know 100% that it's always going to do this, right? I don't even have to try it to know it's going to work, right? That's the cool thing about testing this stuff with linking syntax and stuff, is that this stuff is extremely consistent in behavior. Okay, so let's look over this one more time, just because we've added in a couple things now, and just remember the syntax is really important, right? So we have the response structure defined after here. Okay, we have a markdown syntax here. These actually have no delineation, so they're not actually being. So because of that, we have 3 layers now. We have ones without anything, we have ones with the curly brackets, and now we have ones with the square brackets, right? So this is actually clearly delineating 3 different types, right? So simply by adding in a section that doesn't use this, we're reinforcing the behavior difference between these 3, if that makes sense. Remember, we're in 0 shot right now, or single turn right now. So it's not using any context for this stuff every time we hit enter. Okay, so we should, just by looking at this, we should have a pretty good idea of what's going to do. It should make 10. It should reflect up to 2 sentences max on what it's supposed to do, and then it should make a title. It should make 10 nodes for the initial establishment, and then it should expand them out for each of those 10 nodes. Okay, so this should work. We'll see. All right, good so far. Okay, perfect. Look at that. We're going to have the coolest. I hope you guys are ready to be able to pick the coolest hats for anything you're anywhere you're going. That's the end result of this. This is what happens when you don't give me, this is what happens when you don't give me an input to work with. I'm just going to come up with something random. All right, so that worked really well, right? So zero shot, right? Core functional logic. We have now refined out how it's making the selection of this, right? In an extremely open-ended manner. Remember, because we're doing this in an open-ended manner, we can change this to anything, right? So if you guys want to go ahead and give me some creative, like I'm looking for some actual like creative and complex things that we can unravel and we can try. It can't be generic. Yeah, exactly. So we're gonna get to that next, right? Because the input formulation is a whole separate thing. That's no, not something like that. Something like that's too narrow. Automated closed captions segmentation tools. We'll do building advices here. Help do that. All right, there we go. So this is something that has zero, like the only thing that it has training data on for it is just speculation and theory crafting and work and talk by engineers and enthusiasts about how this could potentially work, right? But either way, you have the functional logic down, so it doesn't really matter what you input, right? It's going to work. All right, Snoop, no problem, man. Take care. I'll have the video up tomorrow. I can only go a little bit longer anyway. We're gonna have to do this. We're gonna be doing this, and we're gonna be building this shit out. So don't worry. It's gonna work, right? But it doesn't really have anything to go off. So it's gonna be very. The depth isn't gonna be extremely deep, just because this is all. It doesn't actually have like a working solution for this, right? It can only really cover like the topics and organize them in a way that kind of makes sense. Okay, so if we look here, it gives an intro, right? Goes over the physics of how this could work, engineering challenges, right, associated with it. We need to overcome zero gravity, a bunch of other, need huge innovations in material science, right? We need huge advances in robotics and automation. And then it looks at the science. It does a pretty decent job, right? This is a lot better now simply by adding in these couple things, right? So now we have a better atomic reasoning module selection in a generalized fashion for this stuff, right? So now we can technically stop going in this direction, right? Now we can start refining things out in a particular direction, right? And let's go ahead and do this real quickly, just so that we can cover the second part in some more detail. Right. So here's the functional logic, right? So this, all of this functional logic, right? This is a response template here. High level, bottom level framing instructions, top level framing instructions, right? And then input here. Okay. I typically am never doing things like this from a single input like this, though. You can, this is best for open-ended emergent behavior, but the more information you provide, the better it'll be. That's typically a hard rule, right? So you can just go ahead and make this a section, right? Remember, I like to use Markdown superstructure for everything, right? So we can go ahead and set that up, right? So you're typically always going to want to start a complex prompt with H1 tag, and actually, instead of defining the intent like this, just go ahead and make the title what this is, right? So you can be like something similar, right? Expert lesson plan course design with advanced. Something like that. Or we can do. We're going to delineate this some more. Role, because remember, GPT likes giving it roles, right? This is not, Cloud doesn't like this, but this is something GPT that's really important, is to define a role. Expert course designer agent. Actually, we'll say expert course designer. Course. I don't know. Let's keep this much simpler. Yeah, we'll. And you don't actually have to do this. This is a simple variable, so what you can actually do is just do this. Expert course creative. Okay. Something different. And you can do description. These are just setting high level and framing of what it's doing. Expert when creates tailored courses and lesson plans and resulting based around the unique user inputs. Unique user input. Okay. So we can remove this now. So this is like the high level. Here, let's go ahead and copy this over. Okay, let's clean this up a little bit. Right, so these are our high level instructions here, right? This is the top layer, okay? So now we've defined kind of what the role is supposed to be and a high level description of what this session is supposed to be, okay? What do we have here? Synthesized. So I've already included this, right? Tailored courses and lesson plan. I've abstracted a little bit to include the course creation as well, okay? I'm going to remove this. Boom. All right. So now we have the main layer established. So now we want to establish some other layers, right? So the layer that is almost always going to be included is an input layer, right? So we'll go ahead and define that here. Let's remove this, right? So input, this is the input layer, right? Now you can add in additional variables here however you want, right? So for example, we can do like topic, main topic. You can do audience, right? Actually, here is what we can do. Remember the very first input we did? I saved this. Yeah, we can cancel. Let's go all the way back. Remember the very, very first thing we tried? It gave suggestions for dimensions, right? And this is why probing is very useful, right? Look, these are all dimensions, right? So I can just look at this now and see some key dimensions that are important, that or at least that it determined are important to tailor this properly, right? So let's copy this, right? Let's put this here just so I can look at it in reference, right? Educational level. So we have main topic audience. So let's now define, let's go ahead and do this. Let's make a tree of inputs, okay? Okay, duration, of course. So this is kind of establishing how long it's going to be. Okay. We have the key topic. So we have the main topic here. We could add in key topics even as well. Teaching resources available, laboratory access. We don't want any of that. But here's the thing. So leaving this, if I don't include something like this, it's open-ended, right? So it might actually come to different determinations for what is available. So I actually don't want it to consider this at all, right? So what I can do in that case is even though I don't actually want it to do anything, I can still add this, but then I can just hard code what the determination should be, right? So teaching resources available. Now, what I can do is none LLM powered social learning. I don't know. We'll just use that for now. Personalized. All right, so I'm hard coding a determination for this because I don't actually want it to consider other stuff, because that's not going to be realistic in terms of what people have access to using for different stuff, right? When specialized, we can always change this, right, to actually consider what there is available, right? But for right now, we can actually we'll just keep it like this for now. What are the learning objectives? Okay, learning objectives. So let's establish the learning objectives too. Okay. Teaching style. Requirements and constraints. So I don't typically, you can add something in for this, but I don't typically add fields for it. No one ever typically use them. I typically have these built into the prompt itself. So like, for example, I will do, let's clear this up. Let's move these up here. Modules, separate this here. This is kind of, this is all focused on its immediate response. So we're going to keep this separate. Okay. So now we have 3 layers. Let's do that. Okay. 3 layers. 1 main layer, input layer, response structure layer. Make sure these are all consistent. 2 H2. Yep. Okay. So now we have 3-layer prompt. Okay. Now we're getting somewhere with this. Let's just go ahead and keep it like this for now. Okay. All right. Main layer, input layer, immediate response layer. Okay. This is as open-ended as you could possibly get. Okay. And I have everything established here as input variables. AI powered collective learning. There you go. I'll use that. I just don't, you have to be careful with this, because if it thinks that like other entities are like required for the process, it'll like form everything around like requiring other people, which is not what we're looking for here, but this should be fine. Okay, so anyways, we have response structure outlined here, inputs framed, and we formed these from a probe here, right? To kind of see what kind of determinations it needed, right? It didn't necessarily have to do that, right? So here's the thing. Let's try another thing now. Let's try this prompt, okay, in a new session, right? But I'm not actually going to include anything here, right? What happens if I just hit enter? It's going to probably say, I need, it's either going to do one on its own. See, this is basically a meta prompt at this point, right? Remember how I was showing what happens when you do this with the anthropic meta prompt? It has a strong enough behavior to replicate stuff on its own. It's the same exact thing, right? When you build this up bottom up, you start creating meta prompts, right? But they're tailored for specific solution spaces, right? So it knows exactly what to do even without any inputs given, right? So that's okay. The behavior is very strong here, right? That's great. But it's not what I was actually looking to do here, right? So let's add a new layer, right? Because we already know this behavior is extremely strong. So all we ever have to do to fine tune for testing is add a new bottom layer. Just remember that it's extremely important. The only thing you need to do to fine tune is once you've seen the initial behavior, right? So now we can do this, right? Add a new instruction and a new layer. When you do this with bottom framing instructions, it supersedes everything before that, right? It allows you to basically understand the previous prompt from a higher abstraction level based on the new instruction, right? So now you could be like, reflect and learn from the above prompt. Populate the input section for various high value high value completions and separate those out. All right, so what do you think is going to happen here? Well, if I had to guess, it's going to start with a quiet reflection, okay? And then it's going to steer into doing this, okay? We'll see. Ding, ding, ding. But it didn't do the code box. Oh. Interesting. You can see how strong the behavior is when you're doing this, right? When you're doing it bottom up like this. Reflect and learn. Look at that, just added in. And here's something else that happens when you start doing this, is that you start getting constantly, increasingly more emergent behavior and stuff that happens, right? When you start adding in bottom layers like this, it'll often do something similar and replicate the behavior on this other layer at the last part of its response. Like this is something extremely common that happens. And this is why commands and stuff like that work so well, is because of this exact thing, right? So these are all different layers of different patterns, right? These all have synergistic patterns. They were all built together and modeled together, right? This has its own patterns. It's an input template, right? This frames things from a high level, right? This sets the exact anchors of the response, right? And this is like high level instructions, right? So when you do this, you can see emulations of whatever you're doing in the responses as well, right? Like you can see how it understands exactly what you're trying to do here simply from delineating stuff in concise manners like this, right? So this is really cool. Like when you see this, you can be like, oh, wow, well, this has some really advanced behavior few shot at this point, right? So now if I were to do things, but after this, it'll have a really advanced understanding of what is going on here, right? So let's see what it did, right? Because remember, I just told it to learn from this and populate it for various high level and separate code box reach. It didn't actually do this correctly because the behavior of this is so strong, and I hard coded the response output that it's going to be really, really, really want to do this, right? But you can see how adding a new layer doing this kind of enters in this behavior regardless from the first part, right? So what it did here is reflected, and then first it created a complex input for itself, and then made the module. See what's happening here now? So something about me doing this abstracted another step before this that creates a more complex input for itself before actually executing the process. See what's happening here? This is basically creating a better input for the process in a self-guided manner. Okay, so this is something really crucial to understand here, is that when you do this, anything you do to delineate things like this only increases the AI's ability to do the same thing as well. The important thing is just delineating the important variables, and then you can actually choose, you can input stuff into any of these and then just let the others be self-determined based on the rest of the context, right? The important thing is capturing the important variables for these different sections, right? Because it's extremely easy to toggle them on and off, basically, right? So let's save this real quick. Just so we can remember, whenever you get good emergent behavior, it's a good idea to save it. Save them, okay? Because then you can recreate it. Okay. So now, what was I trying to do? I was trying to get it to populate this in different ways, right? So now I can do this. No, I wanted you to just complete inputs for different things. No module creation. Right. So it's that simple, right? And actually, by doing this, you can also see how it is interpreting these input keys as well at the same time. So you can see if there's different, if it gravitates towards understanding things in certain ways, right? And then you can actually control this, right? Anything that you're doing like this, you can always go back and add more logic to, just like we did here, to shape the behavior of what it does. So you can add specific options, right? To classify, basically have a mini classification step, right? You can do anything that you think of in this manner, right? So what are we not doing here? We're not actually narrowing this at all to tailor it for specific use cases, right? This is a completely abstracted functional logic, right? That can be narrowed in any kind of way to personalize and tailor things to further and further degrees, right? Because here's the thing, right? It might look like we haven't gotten anywhere yet, but we've already done most of the hard work, right? Because really, this is one way to do it, right? And then you can do one other thing here, right? Add one more layer. AR. Now, if you had a K-rep, something here, right? You could use this as a knowledge base to then pair in as well. So then you could add in inputs here with this as the grounding of the advanced knowledge, and then set anchors with this, right? This, if you had a good KR, this would be a God tier prompt right here, right? But you would want it to have, this would only work in that manner if this KR included information about how to make good lesson plans. Right now, I don't have any logic modeled at all for how to actually make good lesson plans, right? That's the thing, right? I would need to add in a little bit more detail into that in order for that to happen properly, right? But right now, we've just been refining the core logic, right? So let me see if I have a random KR that I can use as a quick example. I have about 15 more minutes that I can do this for. Oh yeah, I do. 1 second. Where are you at? This subject domain one, right? So we'll paste this KR of subject domains here, right? And then let's actually now define some of this. Let's do lesson course. So learning, let's think of something fun. Main topic, learning everything, learning all domains of the universe. We're gonna make the ultimate lesson plan, okay? Key topics include universal mastery, AI, bootstrapped learning. We'll add some complex terminology here on purpose, just because it's going to increase the complexity of what it does. We'll set this. That's it. Audience, prompting legends, educational level, masters of LLMs. There you go. Learning objectives, learn, master every domain in the universe. Duration of course, 1 week. Paper learning. Teaching style, progressive, complexity, please. Right, so now I have this actually filled out, right? And I've also given it a KR. What happens now? I don't know. I've never done this before. But you can kind of have an idea before you do this stuff, what's going to kind of happen, right? It should do something kind of cool here. Let me just look over this one more time. Okay. All right, so let's see what happens. Okay, so it's screwing up a little bit because of the KR, right? It has so much it has so much context on from this KR, right? It's gonna be gravitating towards whatever I gave it, right? So it's ignoring the 10. Actually, it might actually do 10 nodes here, but it might just be combining both of these steps into a single one. That's probably what it's doing. Yeah, it's probably doing both at the same time. Or it's just skipping it altogether. Yeah, that's definitely more than 10. Well, here's the thing. I added a ton of context in here, right? I actually didn't test this before. I did two things at the same time. I added in a complex task on top of a KR injection, right? So because of that, this is a huge change that I added. I probably wanted to, yeah, it's just repeating it, right? So because of that, most of the context that you're injecting here is actually going to be this KR, right? So because of that, I don't have strong enough instructions modeled ahead of this for how to actually handle this, right? So there's two ways to do this, right? I would add some framing here, right? And also touch upon this somewhere here for how to use this. What I'm going to do right now is I'm just going to actually delete this KR because I don't like this isn't actually a valuable KR in this case, right? Because this is just a random clustering of domains that I did as a test on the Discord one time. It was just a random one-shot thing. So it's really nothing that valuable. This would probably be better just removing that in this case, right? Right, so it's actually following the task correctly this time and coming up with its best master speed reading. Learned cognitive strat. Hey, it has a, look at that. This is completely emergent, right? So it's like this is technically hallucination, right? But you can see how it's still staying grounded as much as it possibly can based on actual things, right? Because like from our work and a lot of things that we've done, we can see how this is remaining grounded to a large extent in terms of the things that it's suggesting, right? So this is all novel, right? So what happens if I keep expanding this out, right? Like what happens if I'm like, okay, write the text for, well, no, we'll do this. Which one do we want to expand? Interest in recursive learning models. Let's do that one. We'll just force it to generate something on this, even though and what this is doing is this is basically forcing it to unravel the best possible understanding of how something like this could work based on prior information of training knowledge, right? So you aren't necessarily it's not a given that you're going to get anything good, right? But if you have knowledge behind the scenes of some of this stuff and can probe this in the right ways, right? That's how you can get some quality stuff going, right? So it did its best, right? It's not very deep though, just because it doesn't really have any understanding of stuff to do with this, right? It's just kind of spinning and understanding at a high level of how this could work, right? Okay. There we go. All right, so here, let me I don't have a lot longer, so let me just enable. Here, I turned on. If you guys want, if you guys have any questions, you can talk and ask right now. I have a couple. We can spend the last 10 minutes doing that because we can easily build this out in the next one. Nothing. You guys good?
I'm just waiting for someone else to ask something. I don't have anything, but I just think it's very cool seeming. I gotta brush up on all this stuff.
Yeah, it's no problem. Only not a ton of people here right now, anyway. So it's a Saturday night. I was expecting that. More
Is
chill
it
as
too
fuck.
late? Is it too late to put a few tags in the structure just to demonstrate how it will change the logic?
Yeah, but let's do that next time, just because that's gonna be. I would like to actually integrate that into here because we can add new layers of new different types of
Yeah,
variables to get this to work best, right?
you understand what I'm talking about too, right? Like sparse X and low tagging in your
Yeah, exactly.
logic
Like we can
structure.
find a way to model both of those in here at the same time, right?
Yeah.
You're
Yeah,
absolutely
it
right.
might have actually simplified it, but I didn't mean to get in the way either. So,
No. You're absolutely right. It's just I'm trying to delineate this as much as possible, and then we can add in. It'll definitely make it easier, but we're just trying to add things in step by step.
there's a lot to a really strong meta prompt that isn't easy to convey in a couple hours. It just isn't.
Yeah, I mean, you got to keep in mind, right? Like all I do is work my prompts, right? So I'm just trying to show
Yeah.
this ground up using zero other resources, right? And just probing to do it.
Yeah.
So
I know you did a
this
great
isn't
you did a
efficient,
great
right?
job, man.
But it's the way to learn, right? Thanks, appreciate it. Jimmy, Kevin, do you guys have any questions? Jimmy, I know you're itching to get this realized, right? But by doing this ground up, we're going to be realizing it at the same time, right? Yeah. So like next stream, what we'll do is we'll take this and then we'll literally build out like a full working solution with it, right? That's the plan. Then we can incorporate tool chains and stuff. Okay. So let's save this. Okay. And here's the prompt. Actually, this is what we can do, right? Reflect. All right. Let's do a little bit of AI prompt engineering. I get that. Right, this is also a really easy way to just refine syntax and delineation of what you're doing, right? You can always check it by doing this kind of stuff. All right, look at that. Now, here's the thing. It doesn't actually know. There's the thing about the syntax, right? It doesn't actually understand how the syntax works to improve its own attention mechanisms, right? So it's going to leave some of that stuff out when you do this, right? It's just mostly just to clean up some stuff, right? So let me show you what I do here. Copy. You're never going to use this stuff. You never actually want to use a synthesized prompt. Like that's the thing. You want to incorporate enhancements that it suggests into the master prompt that you have, right? So let me actually. Do this first. It's really, really, really important to save stuff and keep versions of things for a lot of different reasons. I'll show this next time. So let's abstract this. Okay. So the V3 saved, locked in. Okay. Copy this. And let's get its suggestion. Put it up here. It's all the same. Cleaned up the inputs a little bit. I like the this works to help feel good things when you actually add. Dashes. Okay. Yep, that's fine. Keep that in. And see how it has the description in the input at the same time. So this is the better way to do this actually, because it's kind of like how they what they do with the Dolly prompt. As long as it understands that these are notes for what to actually fill in, it's the best way to do it. So let's actually use this section. I like this section better, right? Right, so we got a little cleaner of an input section here. Right. Desired output. Parent module topics. Oh, we don't want that. Additional notes. Right. All right, there we go. This is basically the refined prompt from what we've been doing here so far. Okay. It has main layer, input layer, response layer, and then a high level reminder layer here. This is where you can fine tune things basically with specific instructions. Okay. We can use this and know it'll work, right? It'll either ask for the inputs or it will make its own, right? See? Now, if I were to see how everything that we've been doing has been increasing the granularity of this and increasingly improving this for any kind of input. All right, we don't even need to continue this. All right, we already know it works. What would happen now if I were to use this synthesized prompt? Okay. Oh, shit. You didn't see that. We're good though. All right. And then where the hell is this? Yes, there we go. What would happen if I used this, right? Let's try this synthesized one. Look at the difference. Right. It changes the behavior, right? It removes a lot of syntax. It removes a lot of, it doesn't actually understand. That's important, something important here. It doesn't actually understand how it's impacted by everything, right? So it can only do the best of what I have. If I added instructions in to this generation, basically saying all syntax is really important for attention, it would be actually incorporated then, right? But it's important to be able to understand the stuff and have the knowledge to be able to give that kind of feedback for all this stuff, right? So I never actually use AI synthesized prompts without, I typically incorporate aspects of them into stuff I've already been building, right? So it's just something to keep in mind here. It's a really useful tool to probe and to be able to do this in the first place, right? But you don't actually have to use what it has. It's typically better if you're modeling this yourself. Okay. So let's delete this. And that's the thing about using one that you've built. You can keep the behavior consistent and gradually build upon it to have full control over it, basically, right? I've built every single part, every word of this myself, right? So it's like I understand how everything is working. If someone was to just look at this, it would be like, wow, what the hell am I even looking at? It's just a bunch of variables, and they're like, what the hell is this, right? But when you've been watching it and you've been following with how this is being getting built, it makes a lot of sense, right? It's a key thing to understand here, right? This is completely modular, right? So it's like you can change any part of this to tweak behavior as you want, right? And you can easily expand on it by adding new layers, right? This is the best way to prompt because it turns anything you're doing into a templatable process, which can then be generalized and streamlined paired to different types of tool chains and workflows, right? So that's the thing. This is what I'll be tying into next week, right? How this all comes together, right? Because we're going to be using this as an exact example of how to do all of this, right? All right. Well, if there's no other questions, I'm gonna end things here for now. Get some food. All right. Thanks, everyone. Thanks, Fred, for setting up the stream again. I appreciate it, man. Thanks, everyone, for attending. All right. We'll have a
Hey,
video up,
thanks.
and then I'll do distill and talk. We can talk more on this stuff. Okay. Of
Yeah. Thanks for doing this, Devin.
course, man. Thanks for coming. All right. I'll talk to you guys soon. Take care.